Okay,ครับ so there's a lot of visualization, tools and tricks of the trade that you can play with. Most of the time in my work, flip back and forth between time series visualization and histogram visualization. That tends to be a key thing. But there's another thing that's I'll show you how to do, which is very useful, I think, in your on your projects. Okay, so now, first of all, last week, right? Last week you saw what we did before. How I had this kind of quote unquote logo design. I'm going to give you this piece of code so you can actually use it as a template. Okay, I consider this like a template so you can play with your own design. Now, what I would like to do is take you through how the best practice, let's put it this way, the best practice to come up with interactive design exercise. Okay, so basically the 3-step to it. Okay, there's 3-step to it. First of all, the first part is the design bit. Okay, not interactive, just design, just to get something going. Okay, just to get a design going. The second part is parameterize the design, and allow that parameterization to change. Again, the cylinder, the width and whatnot. And finally, the third part is the animation to visualization. Okay, so you can use this as a template for your thing. Now, I'll tell you which part is unique to this example. So first of all, well, I do this. You don't need to do this, but I tend to do this as well. I always set session so that I work my environment. So in this case, there's a directory that I'm going to put input file, output file, so that's just a good software practice. Okay, let's start with here. Okay, now, so I just took the SC out, just make it simple. So this is the design I came up with, right? Let's say this is the design you came up with. Now, the first thing first, you can do this. You can do all this design, right? You can do all this design and just put in number, put in real number here, put in real number here, and then you get that picture, right? So that's the first step. That's like a step 0. Now, step 1 is to use all those numbers, replace it with a name variable that makes sense, right? Now, because you still make the design this manually, what I would do is put in here, okay? So if I want to do something, let me show you. Is this long enough? Good. Whoa. Okay, so this is the body of the action, right? This is the body of the action. My action is to draw graphic 3D. Okay. My action, okay. My action is to draw graphic 3D, okay. It consists of a few shapes. One is a cone, one is an ellipsoid, one is a cone, one's an ellipsoid, okay. So I'm drawing 4 things, right? 4 things, okay. So again, once you take this home, you can use your own thing, okay. So this is an example. So that's an ellipsoid, that's an ellipsoid, that's a cone, that's a cone, okay. That's a cone, okay. So 4 things, I'm drawing 4 things. Now, ellipsoid means that it doesn't have to be a perfect circle, okay. But in this case, I start out with perfect circle. So instead of drawing this, I could draw this, okay. Guys, pay attention, okay. This is what I draw. There are 3 parts to this. This is what I draw. Now, by drawing this, instead of putting real number, I put in name variable. And I put the name variable over here. And I enclose the whole thing under module. This is a good design practice. What it means is that it's local. So the variable color shaft here, all this thing, all these parameters here is only known locally. So it doesn't affect other parts of the program. Now, this is a little bit of an overkill because you're just drawing one picture, but you can imagine that you have a project that has multiple pictures, right? So you don't want the color shaft here to have an effect on somebody else's color shaft, okay? So the way you do it is module. So module, these are the number that you want to work with. This is the action, and then you're done. Now, I happen to add, again, if I did this, Mathematica is going to give you a nice drawing with the perspective optimized for you, okay? But I kind of like have my own preference. So these are my options. My options say I want lighting to be natural. I want viewpoint to stand this far back. And I want image size to be 300. Okay. So in other words, if I did this, let me do this again. Okay. Let me do this. If I did this and I don't have this option, okay, Mathematica is still going to do it for me. Okay. In fact, it's not that different from here. Okay. So, but I can certainly do this. Right, and get a tiny image. Well, that's too small. Okay, so basically there are two set of parameters. That's what I'm trying to say. One set parameters has to do with the object itself. The other set of parameter has to do with how we view it. Okay, how we view it. Actually, I can also make this a parameter, but I think natural is good enough. Okay, so this set has to do with how to draw, and this has to do with how to view. Okay, so this is my design. Okay, this is my design. So that's step number one. Or okay, once I did this step number one, okay, oops. Once I got this step number one, and let's say I'm happy. I'm happy. What do I mean by happy? What I mean by happy is that all the parameters are contained here. So if I want to do something else, I can't. In other words, if I want to change ellipsoid to something else, not here because it's not an option. So this only tells me what other things I can do. Okay, the shape, the size, the location, the height of the rod, I can do that. Okay. Now, so next thing I do is down here. Now that I'm happy with this, and again, this is I've discovered this is a very good process, and it looks a little bit like too many steps, but I think in the long run it saves you time. Okay, once you figure out that these are the values that you like, you define it separately. Okay, so this becomes, instead of this is the value and this is the action, I encode it as a function of the values. Okay, so encode parametric design as a function of design parameter. Okay, so once I got something I'm happy with, I turn this from constant into a variable. That's what I mean. And this action becomes a function. So I'm going to define this as a function. Function say draw this thing. Okay, so draw 2i. This is my function. That function is going to look exactly the same as before, except instead of having the value embedded here, I'm going to supply it as a function argument. Okay, so now it becomes a function. Okay, now it becomes a function. Now, if I supply this function with those parameters, again, in details, can vary, so you don't have to pay attention. This set has to do with how to draw the eyes, and this has to do with perspective and size of the picture. This is another way of drawing the eyes, and this is another perspective, and this is the same size of picture. So I'm going to do two things. So now, okay, see, So now I don't have to go individually and change the number because now it's a function. Okay, so again, let me repeat the step. Get something going. That's your design process. Once you're happy with it, put the value as a name variable, a name constant. In this case, it's a constant. Turn this constant into a variable that you supply to a function. And then you can call it. So now it's very easy for me to change, right? So I don't have to, I can easily go to and change and say, let's make this all red. Okay. Something like that. Oops, sorry. That's not pretty. Okay. Okay. Okay, so it's now red, right? So I can make this green, completely green. Okay. And do that, right? I can make it smaller, whatever. Okay. So now the design parameter becomes first a constant, then a variable of a function. This is what we mean by functional programming, and this works with everything. Okay, so that's it, right? So this is called parametric design. So first thing is you design it, and then you make it a function. Okay, so now you're done. Go to page 2. Now we can play with it. Okay. So in this page, as you can imagine, I'm going to use manipulate, right? All those drawbar, the buttons and all that. But, I was already happy with the first one, right? So what I'm going to do is I'm going to call those my default parameters. Okay. So imagine that you're going to a client to a design a session. You have an initial proposal that you think is good, but your client can have different view, right? But you have one. So the same value that we use on the last page, let's say I have two design. Right? Let's say I like this set and I like this set. I'm going to name this my default. So instead of one default, I have two default. So I'm going to save it. Okay. Now, this is my convention. Whenever I have a variable that's global, everybody uses, I'm going to make it capital letter. Okay. And maybe add 0 to say, okay, so these are the colors I have. These are the, the first design. This is my second design. Okay. So I'm going to do this. I'm going to set all this. Okay. I'm going to set all this. So nothing is changed. By the way, I can export the picture. Okay. I can export the picture here. Don't worry about that. That's not important. Now, let's go to manipulate. By the way, I want to have a quick reminder on manipulate. And this is not part of this. So if you have a table, okay, guys, table of a to the power I, and I put in the bracket I. Okay. If I have this, what do you think is going to be the result? It's going to substitute I, right, for this thing, number 5 to 9. Now, by default, because this is an iterator, it's going to assume that you mean integer. So it's going to go 5, 6, 7, 8, 9. Okay. So that's it. So it's a table or a list of a to the I going from 5 to 9 in increment of 1. But if you go to manipulate instead of a table, you get the same thing, except instead of the whole list, you get one value at a time, and this is your I, right? Except notice. Can you guys see this? It's giving you all the number between 5 and 9. It's not a strict increment of 1. Okay, so it's continuous. So you have more degree of freedom here, right? What if you don't want that degree of freedom? You want to restrict. You can also do this. I from 5 to 9 in step of 0.5. Okay. And now when you go to manipulate, It does exactly that. So now it goes to step of 0.5. Okay. Now, because this is something that you are going to be using to parameterize, what if your client wants something that in between 7.5 and 8? You can do this. You can manually change it. So now you can put a number in between 5.123 or something. Okay. So that you can do. Finally, okay, finally, instead of putting I from 1 to 5, what if I put another bracket inside? What do you think is going to happen? It's now going to treat it not as an iterator, but a list. So you're going to substitute 5, 9, and 0.5. See that? The difference between with a bracket and without a bracket. And so 5, 9, and 0.5. Okay, so that's just a reminder of how you do this iterator. So these are all the control. Okay, now that's not very interesting. Okay, now let's do our stuff. So what I did was, now this is, remember just now the interactive design, how do I do it? This is a function to draw, and this is my design parameter. Okay. Now I want to make another function, but instead of generating a particular design, it generates a dialogue to implement interactive design. So in other words, I'm going to define another function that has manipulate in here, and that's this function. So I put manipulate inside the function. So now when I call this function, what do you think I'm going to use the variable for? I'm going to use it to initialize. Okay, you see the difference? The difference is this. Okay, watch this. When I draw this function as a function, these are the design parameter. It goes directly into the design, right? It goes to the design. But now I don't want to create one design. I want to create a dialogue so my client, my prospective investor, or whatever can design with me. So I do this. So what are those variables? Now I put in 0 to remind myself that this is kind of like a starting point. So instead of putting it in the design itself, I don't. I put it in the, I put it in here, initialize. Okay. So instead of putting the color shaft as a design, a particular design, I put it as an initial. This is our initial value. And so this is one initial value, and this is a range of value. Okay. And this is my drawing. Okay. So I created a function that draws this particular shape with this parameter. I make this parameter subject to draw bar. You know, people can move up and down, move up and down, move up and down, but I still supply initial value. Okay. Now, I want to be a little bit more fancy, and this is, you don't have to follow by this. I actually make a button that reset things or set it to my design, okay? So let's see what happened. So now, okay? So now I create the interactive design. See? The design parameter that I had frozen before becomes initial value, okay? But it's an initial value that your clients can now change at will. Okay. Okay. So now I can change. Now, this is the design parameter that I was telling you about, right? So it plays where the first one, the second one, far left to the right and close to each other. This one is lean. Okay, so we can make it lean a lot or not so much. So that's the angle. We can make the radius. We can make the aspect ratio of this thing. So again, it's an ellipsoid. Okay, so I can play around with this all I like. Now let's say my client say, oh, I messed up. I want to start from the beginning. Okay, these are where the button came from. Okay, so this go back to reset. Go reset and go to, okay. Okay, now it's good. Okay, sorry. There's a typo there. Okay, so let's say my client messed it up and I want to go back to original design. Okay, I want to go to design number 2, design number 1, and blah, blah, blah. Okay, I can also make another button that saves this, but it's not in here. Okay, so this is step number 2. Okay, now, as part of step number 2, because when you have the mathematical license, you also have a little bit of cloud space. It's a temporary cloud space. So what you can do is you can deploy this. Okay, you can deploy this on a cloud. So let's say I'm deploying this. Okay, you actually have this now because it's you haven't paid for it. I think the cloud space cleans up every 3 months or so. Okay, but certainly if I want to show something to my client and my client doesn't have Mathematica and I don't want to carry my laptop around, what I can do is I can deploy this as an app. So this app will appear on the internet. So I can ask my client to, okay, well, I have to sign in, sorry. I forgot my sign in. But anyway, it's just gonna look like this, except it's cloud deploy, okay? So that's it, so you're done, okay? So that's my second step. So first step is to get the design going. Second, and then make it a parameterized function. Second step is to make it interactive. Finally, third step, and this is where I do animation. Now, my animation, okay, and this is good reason why I have 2 design. I can interpolate, right? I can interpolate between, let's say I have one design has a diameter 1 inch. The other design has diameter 3 inch, right? I can interpolate, right? So that interpolation is called this, subdivide. Okay, subdivide. So I can subdivide colors. I create my own function to subdivide colors, for example. So now I can divide color from red to blue by incremental, okay? But I can certainly create all kind of subdivision. So now I'm gonna say, I'm gonna make a 10-step GIF. You know what a GIF is, right? GIF is like animated picture, but it's not a real motion picture. It's just screen, 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 screen. So in this case, I don't want to make too many of them. It wastes too much space. I think 10 step is enough, okay? So what I'm going to do is all the design parameter. Now I have 2 design parameter, if you recall, right? So I have 2 design parameter, one here and one here, right? And also perspective, look from above, look from below. So what I can do is I can make picture by picture by picture snapshot. So this is basically all I do is just subdivide, okay? Now, once I subdivide, this is how I do animation. The animation is very easy, right? Very easy. All I do is, remember that table? I just increment in step. I just draw one picture. Oops. So all I do is draw one picture, one picture, one picture, one picture, 10 of them. So this is what it would look like. So let's say this one. So that's picture number 1, picture 2, 3, 4, 5. You notice the shape is slowly changing, right? So what happened? This thing is short, blue, purple. It's getting longer. This thing is getting squeezed. This thing longer, getting squeezed. The color changing also. It's now becoming green. It's becoming green. It's becoming green. So in 10 steps, I changed from the original picture to that. That's it. That's all I did, right? So basically, I have one design parameter as the beginning and one design parameter at the end, and I subdivide the design parameter, okay? You can do trickier things than that, but this is plenty. And this is enough for you to get going on your project. So now I have 10 pictures. All I need to do is I just do this and I export it as GIF. So I export it as GIF, okay? And in fact, once I export it, it becomes this picture, okay? Where's the GIF? I have to look at this. Okay, so this one, I didn't change the design parameter, but I changed the perspective. Oh, I changed the design parameter, right? So this is the one we saw, okay? So this shows my client the range of design parameter that I think is good, okay? Again, do whatever you want, your design, your thing. It's not my thing. This is just something that I play with, so I use it as an example. You can also, and here's a neat trick. That parameter that has to do with perspective, it's X, Y, and Z coordinate. If the depth coordinate is very far back, it's the same thing as looking at 2 dimensions. So in that case, you can look at this. Oops. Hold on. There, see? So instead of changing my design parameter, I change my perspective. I pull back. And if you pull back far enough, everything looks 2 dimensions. So this is another trick that I want to give you is don't design 2D. A lot of the design school would tell you that start with 2D and do extrusion. I actually suggest the opposite. Go with 3D design. And if whenever you want to do, to do 2D, just pull back. When you pull back, everything looks like a 2D. Okay. Now this one, I'm changing both the design and perspective. So that's it, you're done. So this one you can have, I'll give it to you. And okay. So that's that. Okay. Right. So you can use that as a template. Again, template means substitute your thing. Where do you need to substitute? The design and the design parameter set, right? I separated 2 things, design and perspective. You can play with just one thing or the other, okay? This is more like capability of Mathematica for visualization. It's a lot more interactive. And again, I don't need to show you this. This is a nice one. This one actually used geolocation. I just want you to briefly show you this because not only is this this depiction of countries in the world, cities in the world, it's also giving you the shortest path. Because here I make a calculation for the shortest path. Okay, but anyway, so you don't need that. And you can use any kind of background picture. You can use a satellite picture. You can use a coastline. You can. It does take some time, right? Now, what's cool about it is that you can also use different projection. Okay, so all this is very interactive. Again, it's interactive display of geographic information. Okay. It is a little bit weird. So I don't know what that is. But anyway, so same data, different visualization. Okay. Now, you know, of course, the difference between this, right? And this. This is more realistic because the country size is realistic because it's more projected on the globe. But if you stretch it out, the country up north is going to look really big, but it's not that big. Okay. Right. Okay. This is similar kind of thing. So I'm not, I don't need to show this. Right. Now, this is something that, remember the two classes, right? The previous class is about designing an interactive design. This class is about visualizing data. So now I'm going to do visualization of the data, but I'll take you through similar kind of step, right? So this one is also a template. Okay. But this one is much cooler. Okay. Well, than what I was telling you. Now, again, this is my set session. This is just to say where I am. That's not important. Now this thing here, I simulated the data. This is the part where you would import your own data. Okay, let me say that again. You can use this template for your project, but this part will be different. Okay, so this part I am simulating. The reason I'm simulating because I want to demonstrate something. Now, you guys don't know this, but I deliberately designed this as a 4-dimensional data. Let me say that again. It's 4-dimensional data. It has 500 points. Each point has 4 numbers. Okay. Why do I make it 4? Because it's not that big, but it's bigger than 3. I want to show you that you cannot do 3D visualization. What can you do? Okay. So now you can visualize 2D dimension. You can visualize 3D. Okay. All right. You cannot visualize 4D, 5D, 6D, but 4D you definitely can't visualize. So I created artificially 500 data points in 4 dimensions. I also created intentionally so that the data cluster into 6 groups. Okay. In real life, it depends on your data. But in this case, I want to demonstrate a concept. So I make this data, I design it for the class. Okay. So you guys want to see what this data looks like? Well, this data is called sample. Okay. So I can go to another page. Okay. So this is my sample. Okay. It's a list. It's a list of lists. The first one has 4 numbers. The second one has 4 numbers. The third one has 4 numbers. And how many of those do I have? 500. Okay. So it's 500 times 4 numbers. Okay. Now, how do I know? You can do this. Okay. Now I generated this, so I know it's 500 times 4 number. But let's say you download this from the internet. How would you find the dimension of this? Well, you just say, what's the dimension? Oops. Okay. Dimension of sample. Okay. 500 by 4. 500 rows of 4 columns. That's basically what it means. Okay. By the way, in the code, okay, look up a minute. This means the same thing as this. I can use @ for simple. It's the same thing. Okay. So sometimes you see that. Okay. Now, this is not as useful because you can only follow with one thing. But if I do this, sometimes some function has more than one parameter. So I can put comma, something. Okay. Fine. So let me ask you this question. Well, this is rhetorical. Can you tell that the data fall into 6 clusters? Can you? You can't, right? It's all messed up. Anyway. Well, this here, This here is to find the cluster. Okay. Now, this is not part of your class because you're not learning clustering analysis. That's part of data analytics. But, you know, it's so simple. I'll just show you. Okay. So what I did was I have 500 data points. Each point has 4 numbers. So it's 4-dimensional number, but they tend to cluster together. And I designed it to make it 6 group. So I create this function called cluster. And so now instead of working with the original sample of 500 points, I'm going to work with 6 clusters of data. Okay. Okay, 6 cluster. And now I told you that you cannot look at 4 dimensions, right? But just for the sake of illustration, I'm looking at all the 6 cluster, but I'm looking at dimension 2 and 3. Now, don't ask me why dimension 2 and 3. I created this data set to demonstrate a point. Okay. You will see that dimension 2 and 3 is what is important in terms of distinguishing cluster. You will notice that the first one cluster around number 5. The second one on this axis cluster around number -6. So positive, minus, positive, 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 positive. And you look at the second axis, you see that that one cluster around 0, that one 0, negative, negative, positive, positive. I made this up. I made this up. Okay. So it's 4 dimension, but I design it so that in 2 dimension, 2 and 3, it separates things into 6 cluster. I want it to be that way. In fact, dimension 3 is also separate, but okay. So this would be sort of like data exploration step, but you know, that's not important. Again, it's not a data analytics class. Okay. So this is where you come in. Okay. So first thing first, you have to find out how many data points and how many dimensions. And that's what we did before, right? Dimension. Except I have to use the word flatten here because it's a list of clusters. So I have to flatten the cluster out, but never mind. It's not that important. So that's the number of data point. That's a dimension of the data point. Again, 500. Now, what else do I have to find out? I find out how many cluster. Now, I know it's 6 because I made it so, but you have to find out, right? So find the length of cluster. Okay. Length applied to cluster tells you how many clusters there are. 6. Length / apply means apply to individual component. So it goes to each cluster and counts the number. So the first cluster has 76 data points. Second cluster has 73. Third has 91. Fourth has 86. Fifth has 97. And the last one has 77. If you add them all up, you should get 500, right? I designed it this way. So I make a 500 data point that artificially separate in 6 clusters, and those are the 6 clusters. So this would be like you come into a data point set and you want to visualize. Again, your job is not to find the cluster, right? That's data analytics. But let's say now you got the data into cluster, you want to visualize. That's your job now. By the way, I can do this cluster size divide. What does that give you? It gives you sort of like allocation as a percentage. So it's a nice, so it's saying that 15% belong to cluster 1, 14.6% belong to cluster 2, 18.2% belong to cluster 3. So it's fairly evenly divided. Okay, fine. Okay, so you got that. So you got the data, right? Now the important part. Okay. Remember, we have 500 data points into 6 clusters. Can you visualize all 500 data points? No. Okay, so this is too much. If you think 500 is not too much, I can make this example 5,000. Okay, but it's too much. Okay, let's say you don't want to visualize individual data point, but you know that the data exists in cluster. So wouldn't it make sense to just look at the representative example of the cluster? That makes sense, right? That is a concept called centroid. In other words, if this is one group of people, they have similar height, similar weight. This is another group of people, different, but within group, similar height, similar weight. I can't look at all of you. I can take the average height and average weight. I can take an average height and average weight. And that represents the center, quote unquote. And the word is called centroid. So centroid is kind of like an average in whatever dimension of the cluster, within cluster. So it's not averaging the whole class. It's not averaging the whole 500. It's averaging one cluster at a time. So how many clusters do I have? 6 clusters. How many such averaging do I have? 6 averaging. So, and this is so simple. All you do is, again, centroid is this. So you apply mean to each cluster. So now instead of having 500 points, now I have 6 points representative of the cluster. So cluster 1 here, the mean is this in 4 dimensions. Again, I still can't see 4 dimensions. I still can't visualize 4 dimensions. Now, how would you identify or visualize this point? Okay. Right. Again, what was I trying to do? What was I trying to do? I was trying to do comparison, right? I'm going to compare 6 different clusters. Okay, I'm going to compare 6 different clusters. I'm going to compare, right? So there are 2 tools here that I mentioned. One's called bar chart. One's called radial axis plot. Let's try with bar chart. That's a bar chart. Okay. So I apply bar chart to centroid. I get this. Okay. Do you know what that means? That's a terrible graph, right? But I'll tell you what it means. The left one is the mean of dimension 1 of the first cluster. Next to it is the mean of the second dimension of the first cluster. Next to it is the mean of the third dimension of the first cluster. So 1, 2, 3, 4, that's group 1, cluster 1. And then cluster 2, 3, 4, 5, 6. So yes, you can use this to compare. My question is, if you walk in half a second, you get the picture, right? So human beings are not good at anything more than 7. Okay, this is your magic number, right? Anytime you have something more than 7, human beings don't like it. How many lines do we have? That's 24 lines, right? Nobody gets a picture. Nobody gets a picture. So how do I make this manageable? Something smaller than 7. Well, I can look at one cluster at a time. That's another option, right? So I do this. So instead of looking all the centroid, I look at, instead of looking at all the centroid in all dimensions, I look at one dimension at a time. So I can do this. So instead of looking all the centroid, I look at all, but one dimension at a time. So dimension 1, 2, 3, 4, right? So this is the mean of dimension 1 of cluster 1, 2, 3, 4, 5, 6. So yeah, it's different, right? But the thing is, I have to go one at a time, right? So this is cluster dimension 2, dimension 3, dimension 4. I can do this as well. Let's do this. instead of looking at all the centroid one dimension at a time, I can look at all the dimension one centroid at a time. Okay, I can do this, right? And actually, how many centroid do you have? Well, centroid, right? Now, what are you looking at? Dimension 1, 2, 3, and 4 of the centroid of the first cluster. 2, 3, 4, 5, 6. Yeah, they're different. Okay, so that's better. That's better. All right. So I can't look at 24 numbers. I can look at 6 numbers and 4, one at a time, 4 times. Or I can look at 4 numbers at a time, 6 times. Okay, that's a little better, right? But can we do better? I maintain that with radial axis plot, not only can you look at the centroid together, you can also look at the size. See, I haven't told you, the size are different, right? It's, okay, so let's look this. So let's go to radial axis plot. First thing first, radial axis plot. Okay. Now, this may not look that obvious to you yet, but it certainly is a nicer picture because it shows you 24 numbers at once in a way that you can recognize. What it means, each line is a centroid. Okay, watch my hand here. One centroid here, this is dimension 1, 2, 3, 4. So the blue line, this is 1. So one of them, one centroid is like this, the other one centroid is like this, the other centroid like this, the other centroid like that. Well, trust me, this is a nicer picture, but it doesn't look yet. It doesn't look that nice yet. All right, because first of all, the line is too thin. The line is too thin. Moreover, the line is not representative of the size of the cluster. So what I do is this. I make the line thickness proportional to cluster allocation, and I did this. Okay, now, I just made this example before lunch, I think. So I didn't have time to put in the label 1, 2, 3, 4. Normally, there should be a legend like a blue for the first cluster, right? But right away, you can see that one cluster has high value of x1, high value of x2, low value of x3, high value of x4. The other cluster has low value of everything except x1. The other cluster, you see what I mean? So this is called radial axis plot. This is one of the most concise and useful visualization tools that you will have. Now, everything else, line plot, a matrix plot, dot plot, those are useful, but they're quite easy. So that's why I didn't go over in detail, okay? But this one is useful, but it does take a little bit of work. Now, this would be like design. Let's say, you know, I'm not quite happy with this yet, but let's say I'm happy with it. I'm happy. This would be like the first design we got. So now let's think of make it interactive, okay? So you can make so many things interactive. So let's do this. So let's see, we can start to manipulate stuff. Now, first thing first. First thing is I did exactly the same thing, right? But now I allow this line width multiplier to be small, larger, larger. Again, I'm using 1 to 5 scale because it's using, say, let's say something like this. Okay, well, that's too much. So I'll go back a little and dial it down a little bit. So now I manipulate, right? So now I can manipulate. So this is not like your client working with you to auto design. This is like your client choosing the design the display parameter. So it's not a design parameter now, it's a display parameter. Okay. So next step, let's add a little bit interactivity. Okay. So now, not only do I do this, okay, I make control type radio button. Okay, this is like option now. Okay, this is like being fancy. So control type is a button, and I put the control at the bottom. So the control at the bottom, see, so it's nicer than this. This one I have to click down. This is the one that Mathematica does automatically. Now, normally click down is pretty good, but let's say I don't like it. I don't like it. So I make it a radio button. This is an old terminology. You guys never seen this. In the old days, in a car radio, you can change the station by pushing. So that's why it's called radio button. Okay. So now there's interactivity. Now I'm going to make it like before. Okay. So I'm going to do set default parameter. This becomes a function that calls, all this goes into a default, and there it is. Okay. Now, I did more than that. I didn't just encapsulate the design. Notice that all the calculation that we did before, I sneak in here as well. So now this one function here, okay, if you're going to copy one function here, you can copy this function. And this function will work with any cluster information. So this step, right? All this thing here we did before. Okay, the data, the number, the dimension, all this. Yeah. So all this becomes inside this function by putting it inside the module. So now with this thing, you're done. Now, how would you work this in practice? Again, let me trace a step. The detail doesn't matter, but the detail, here's a step. You get some data. Okay. You get some data, you explore. Okay, this simulate is my step because I created this data. So in your real step, it would be something like download data from source, say internet. Okay. You can explore data. Now you can find out this. Okay. Once you're happy with the display, you're happy with the display, that's radio axis. Then you create manipulation so that it allows, you can allow certain things like I can show the label, I can normalize the scale. There's so many things. I just made this example before lunch, so I didn't have much into it. Okay, but there it is, and then you encapsulate. So now you have this function that for every cluster data in any dimension. Now here's again, if you have 4 dimensions, it would look like this. If the data comes in 5 dimensions, what would it look like? Well, we can do this. Why not? Okay, let's go back. Okay, I'm faking this now. I'm faking this now. Data. Okay, so my cluster number 2 has something like x3 plus x4. Okay, I created another dimension just out of nowhere. Okay, so now this cluster is 5-dimensional. So now instead of viewing the cluster number 1, I view cluster number 2. Now it's 5 dimensions, right? So now you are pretty agile, right? You can go anywhere you like. All you need to know is that I am working with a list of cluster. Each cluster is a list of data point of whatever dimension. And based on this, you know, I can now in a real application. And in fact, I use this in my consultancy project, but of course I can't just show like this, right? I had to label that this is whatever statistic, this is whatever statistic, there's whatever statistic. So there's a lot more detail the labeling and all that, but you get the picture. Now, can you see now that this shows you that there are 6 clusters? There's a tiny cluster that has this centroid. There's a big cluster that's sort of like low value everywhere. That's a big yellow one. There's a blue one that's sort of like a medium-sized cluster, but big everywhere, right? Now, between this and looking at bar chart, which one do you think you can look in half a second and get the picture? It would be this, right? Okay. So that's it. That's the whole essence of data visualization design. Okay. So again, a good, now I don't know, let's say if this were an exam, okay, if this were exam, okay, I can give you something like this, or I can give you the bar chart and I ask you to critique. You can say from a human cognitive standpoint, the bar chart is not good because you can only look at a few things at a time. If you look at everything more than 7, I can't do it. I can't handle it. It doesn't give you the size. It doesn't do. This one is good, but it's still pretty bad because the color scheme is not good. You can say that. You can criticize that. You can say the color scheme that Mathematica picked kind of like obscures. So maybe you can use different color scheme, like a rainbow or something, red, RGB, whatever, right? Okay. So that's the whole essence of what I mean by data design. Okay. Okay. So that's that. I'll give this to you after class. I think there was a typo I want to finish. Okay. ครับ okay. Yes. In fact, I plan to do that. We have like, I don't know, 10 minutes or half an hour. Pretty good. We're pretty good. You guys, first of all, I'll give you 3 minutes to sit in groups. Can you guys do that? Okay. Just arrange yourself. You can use the same group, different groups, but sit in groups. Or are you already in groups? No? Okay.
they can decide to bring and the members, then they can send to the line group.
Okay.
So then I can rearrange.
Okay. 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 Yeah. Once you got the name, then you have to tell. โอเค น่าจะเสร็จแล้วนะ Okay, guys, start sitting down. Well, definitely, go to this page. Go to this page. Okay. Or type in like this. Type in like this. Example data statistics. Actually, you can do this. You can go to type example data, right? I just typed it in. Open bracket, close bracket. Now, if you go F1, it's just gonna give you how to access, but that's nothing. What it means is this: instead of, because you can bring in any data set you like for the project or for this week assignment. It's not really a project, but I would suggest that if you go to example data, you can download from there. So basically, within Mathematica, some of the example that data that they use is already there. So you don't have to worry about sourcing from the internet, downloading it, eliminating zero, counting, repeating, whatever. There's a lot of painful data cleansing exercise you have to do. Okay, ask your friends in data analytics. It's actually not that enjoyable to get a raw data and clean it yourself. So this is kind of curated data. So it's not even curated data. It's even better than curated data. It's example data, meaning that they shows this to demonstrate certain feature. Okay, so the data is very clean, easy to use. You can use anything. Okay, now there's picture data. There's so if you go to example data just by itself, type in data without typing the type, you see that this aerial image, audio data, color, data set, geometry. Now I tend to play with statistics data quite a lot. Okay, so but you can do whatever you like. You can do what you like. Some of you may like more picture. Okay, but I think from data visualization, if you restrict yourself to example data statistics, okay, in this case, I type in the length. So it's actually 111 modes, module, okay? So in statistic, there's airline passenger mile, airplane. So this is from A to Z, okay? So this is within here, I think there's plenty for you to pick from, okay? So each, everyone, I don't care, just one person from your group, just go in and then do this. and basically pick area that you like to play with, and then go into there. And there's a lot more, right? So for example, if I go to statistics in Old Faithful and I type in properties, so maybe I put this. What's the name of the class? This one? Okay, good. Okay, so first thing first, let me before I forget, let me just give you the file that we were playing with today. Where is that? Okay. So I'm going to give you this file. Oops. I'm going to give you this file, and yeah, that's good enough. Okay. So let me give you that document. Okay. Okay. For some reason, I like to zip first. That's fine. So this is the centroid cluster visualization. This is, so use this as a template for your homework. Okay. So chances are you can do two things. Okay. First, and I'll let you guys decide. Do you want to make it a design exercise or data visualization? Let's make it simple. Okay. If it's a design exercise, it will be something like last class, except you do something more obviously. Okay. Visualization, I suggest it's going to be better because it's something new. Okay. Now for data, for this, you should go to here. Just type in this. Yeah. Yeah. Now, and let's say you, for some reason, you happen to be interested in this example here, Old Faithful. I don't know. Have you guys been to West Coast? Well, not West, but Yosemite. So this is data that has to do with Old Faithful. Old Faithful is a geyser, guys. What it means is that it's a hot water. น้ำพุร้อน look. Geyser is a น้ำพุร้อน It shoots hot water every now and then. Now they collected the data of how long between explosion and how long the explosion. So it's a waiting time versus duration. In this case, it's very simple. I use this for demonstrating. Very simple. Here, see, duration, waiting time. Now, this is as simple as it gets. Why? Because there are only like, I don't know, 200 data points. You can see all of them. There are only 2 dimensions. Okay, so you don't have to worry about, oh, am I going to do bar chart? Am I going to do radial basis, radial axial radial part? So basically, this is minutes. Okay, if you wait 60 minutes, and there's a point there, say you wait 60 minutes, and the explosion lasts for 2 minutes. Okay, now, do I need to do anything more? I show this picture, you get it, right? Right? What can you tell me about this? You can tell me 2 things. That there's a positive slope and there are 2 clusters, right? I don't need to do any more, you know, radial axis plot because it's only 2 dimensions, guys. There's only 2 clusters, right? Look at this. You get the picture. You're done. You're done. What it means is that sometimes you wait around 60 minutes and you see the explosion around 2 minutes. Sometimes you wait around 80 minutes and it lasts about 4 minutes. What does it suggest? What it suggests is that underneath the Yosemite National Park, there's like a cavity, and hot water, or you know, builds up until it gets to a certain point. The pressure is too high, it blows. This seems to suggest that there are 2 cavities, the big one and a small one. Okay, a small one fill up fast and then lasts for 2 minutes. A big one takes longer time to fill up, but you know, it lasts longer. Okay, so that's it. That's it. So this would be, so if you if I'm interested in this data, okay, if I'm interested in this data set, I just type in this. And it tells you what column heading. Now, there's only 2 column headings, so that's not very interesting. So go to here. Okay. Oh. Properties and the column headings. Okay. Now, property is going to give you a rough idea about, you know, how many data points and whatnot. Column heading, literally the name of the variable. Okay. So in this case, it happens to have only 2 variables. So that's not interesting. So try something else. So let's say, I don't know, Mark Twain authorship, let's say. Okay. Word length, Mark Twain, you know, whatever, you play with it. So the idea here is, and I'll leave you some time to do it. Discuss among yourself, and I'm sure you guys are gonna get pretty loud, so I'll leave the room because I don't like that. Okay, choose before you go home today, right now, choose the data that you think has enough complexity to play with. Okay, so obviously 2 dimension, 200 data point, that's not gonna get you anything, right? Okay, on the other hand, there's some very detailed big data set, multi-dimensional, that you probably get lost in. So play around with this. I have no idea. I cannot suggest anything. I have no idea. I haven't looked at all of them. So this is one of those things. So instead of, you know, searching the internet for it, if you search within here, life is going to be a lot easier because it's curated data. The word is curated, meaning they clean it, they put the names on it. There's no missing data point, I don't think. Okay. So do that. And again, you're welcome to be as loud as you like now. So now, so once you've done this, decide, go through the menu I told you, right? If the data has too many dimensions, how am I going to present this? If it's a social network data, maybe you use a matrix plot. So I would think that once you've decided on the data set, you start thinking about of the 6 items here. Basically, before you go home today, you should have a rough idea. Let's say I want to take this data set and I want to use A, B, C, D, E, F, G. So chances are, I don't think vector field plot is going to be applicable to your case. So there are 7 more choices. 1, 2, 3, 4, 5, 6. 6 or 7? 6, okay? So you should be able to decide. Now, some data set may require that you use time series to display part of it, and you use maybe composition plot to play part of it. And this happens all the time in finance, for example. So for finance, I can say, this is my time series of Bitcoin, this is my time series of stock price, and this is composition of market size. So I use both the composition plot and time series plot. Okay, so I'm not saying use one, but at least before you go home, you should have idea of at least one. Yeah. Next mine? Yes. Let me send it to you right now. Yeah. Okay. And again, I don't want to just one plot, right? This is about interactive design and choice and all that. So use the template that I gave you, basically this one, right? But the difference is instead of centroid, it'll be something else. Instead of the data that I simulate, it will be data that you just downloaded. Okay, but try to follow that. Okay, and same way as the homework, all the plot will have optionalities, right? Options. So if you click and press F1, it will go to the help page and will give you the list of options. The more options you have, the better, right? So play with perspective, play with height, label. Yeah. Let me make one thing mandatory because I didn't cover it in class, labeling. Okay. I didn't show you any labeling example, but you can follow that. So make sure you have good labels. Okay. Again, this example I just did before lunch, so we didn't have time to do label for you guys. Okay. Have fun. And as soon as I leave the door, you can be as loud as you like, but give me a head start. Okay, ครับ